All right, so today we're going to be going over how to do the second airfoil, which is like a little bit of a diamond shape. So first we're going to go to geometry and we're going to create our design. All right, so here's our design. We're going to go with this little triangle formation. It's raised at about 5 degrees and then angled 5 degrees on each side. And then we're going to be experimenting with this. And then next we're going to go to our workbench. I'm going to show you this, and we're going to mesh it. So you're going to go to mesh, select small 0.0014 as your mesh, and then right here you're going to want to create an inflection around these points right here, and it's going to give you a way more defined mesh. And also, before you move on, like before, you name it wall for the outer, or for the triangle, that'll be your airfoil, and then for your far field you just label the outside of it, and that'll be your far field, and that'll calculate the velocity going through it. All right, now we just switch over to our last thing, which is Fluent. We're going to run analysis, and you should get something that looks like this. First, go to general, go to density based. Then for models, you're going to want to have viscous and viscid energy on, and then go to inlet, or actually first go to fluid. Air, and make sure it's ideal gas and not anything else, because it relies on density changing. You're then going to go to your inlet, and you're going to select far field for where you labeled far field. It's going to show up as wall, but change it to far field. I use Mach 2.5 for this one. And then you go over to initialize, and then you go and hit run calculation, and it should run a calculation at about 1,000 iterations, and then use it to steer towards supersonic. And after that, you go to controls, control 1, and then you can get pressure, which is this, and then for Mach number, go to velocity, then Mach number. And that's your streams for your Mach number. Now to get your report definitions, go to report definitions. Here I created one. Let's create a new one. Let's say force for lift coefficient, compute. First select the wall. There you go, you should hit 3021. Now, after that, we're going to want to get our drag coefficient. So we go to new, force report, drag coefficient, click from the wall, compute, and then we'll get our answer right down here, which we got 371 and 3021 for the one. All right, have a nice day, everyone.